Hi, in this video we're going to define rational and irrational numbers. In this first screen we're going to define it, and then the next one I'm going to give you more examples. So here we can see that a number that can be expressed as the ratio of two integers is called a rational number. That's the simplest definition of a rational number. This is more explanation on that. Let me just give you a few examples here itself. For example, the number 3. Is that rational or not? How do we decide? So we should be able to see if I can change 3 to a fraction, which I can because the denominator is 1. So the number 3 could be expressed as the ratio of two integers. See, the numerator is an integer as well as the denominator is an integer and is expressed as the ratio. That means in a fraction form, right? So since I was able to express 3 in this form, 3 is called a rational number. So what about the number -5? Is that rational? Yes, it is, because I can express -5 as -5/1. What about 0.5? Is that a rational number? Can I express 0.5 as the ratio of two numbers? Yes, I can. I can write 0.5 as 1 divided by 2. So 0.5 is also a rational number. Now, the only time when we can have a doubt is when you get decimals like 0.333 and this decimal does not end. Is it possible to change that into a fraction? Actually, in this case we can, because this is a decimal that repeats. We can see that there's a pattern here. 3 is repeating. So this actually is the fraction that corresponds to this decimal is 1/3. When you divide 1 by 3, you get 0.33 and a 3 that repeats. So since this decimal could be written in the form of a fraction or in the form of a ratio where 1 and 3 are both integers, this decimal here is called a rational number. Okay, that's what it means by rational number. Anything which can be converted to a fraction form and it can be written like that is called a rational number. Now let's focus on the definition of an irrational. Any number that cannot be expressed as the ratio of two integers is called an irrational number. Now let me give you examples on the next screen, and then we can talk about more examples for irrational. Here a few examples for rational, where 3, because 3 could be written as 3/1. It could be 0.75. Is 0.75 a rational number? Yes, because it can be expressed as 3 divided by 4 as a ratio of 3/4 or as a fraction 3/4. So this is rational. Another one, let's say 1.33 and 3 repeats, or 1.3 bar. So this is also a rational number. We know this is 4 divided by 3. So since this decimal, since I could express this decimal as a fraction like that, that was also a rational number. 1.33 is also a rational number. Now irrational numbers, examples for irrational numbers are pi. Whenever we find the area of a circle, we use pi. Pi is an irrational number, and the decimal that is equal to the value of pi is approximately equal to 3.14159, and it keeps going. There is no pattern for the decimals that come after this decimal point. There's no pattern. It doesn't repeat in a certain order. We just don't know what's the next number just by looking at these numbers over here. It's not going like 141414. That's not what's happening here. So whenever that happens, it's called an irrational number. Okay, another example for irrational number is the Euler's number E, That's another constant that we use in math. 2.7182, and it just keeps going. It does not repeat and it does not end. Another are square roots of numbers that are not perfect numbers. For example, square root of 2. We know that 2 does not have a whole number as a square root. So when we put square root of 2 in a calculator, we get the answer as 1.414213, etc. It keeps on going. So no pattern, does not repeat, does not end. Another example may be radical 3. We know that the square root of 3 does not have a whole number as a square root. It's a decimal. 1.73205. It goes on forever. There are two things that are common for all these numbers if we think about it, okay? They do not repeat, or in other words, there is no pattern for the decimals, and they do not end. They do not end. So you can ask a decimal this question. So whenever you're given a decimal and you're asked to find out if it's rational or irrational, then you can ask that decimal two questions. Does this decimal repeat? Does it repeat? Okay. Does it repeat? Does it end? Ask the decimal two questions. Does it repeat? Does it end? If both the answers are no, no and no, okay, if both your answers are no, then that decimal will be an irrational number. So I just want to give you a quick trick on how to remember this. We've all learned that two negatives makes a positive. That's something that's always in our head. We know that two negatives, when you multiply, you get a positive. Connect that to this. Sometimes it'll help to remember. Two negative answers to both these questions. Alright, two negative answers gives you an irrational. No to the first question, no to the second question means the decimal is irrational. Alright, two negatives gives you an irrational decimal. And the negative answers are for the questions, does it repeat, does it end? It should not repeat and it should not end. The decimal should not repeat itself and should not end. If that's the case, it's an irrational decimal.